Hi class, welcome to week 5, the beginning of chapter 31. This is where we're going to start to talk about a little bit of math. And really it is just simple algebra, so don't overthink it, don't get nervous, you're going to do just fine. Just remember to set up your ratios and get into a routine and really develop the same approach each time you do one of these problems. So your reading for the week is page 881 to 886. You need to, before the week is out on Sunday at midnight, you need to complete the week 5 forum with an original post of 250 words and a reply to your classmates as well of at least 100 words, and you need 2 of those. As well, you need to complete week 5 assignment. And if you have any questions, as always, I'm available by email. And I will be posting midterm grades up through week 4 by Monday night. I've already got some of them pre-graded, so you can peek in there and see your test score or maybe your assignment score in Moodle, and I'll be entering those into Sonus tomorrow. So, let's see. To properly prepare a medication, and this is going to show up again on a test, so pay close attention. The medical assistant must be able to read and comprehend the physician's order, read and comprehend the medication label, and calculate the appropriate dose, as well as educate patients on how to take their medication. They can also assist the patient with understanding warning labels. And this is all sort of sometimes what a pharmacist does, so you're kind of mirroring what we'll do. And you're doing this to double check the order that we put in, as well as make sure that the patient understands exactly what they're getting. So a medication order should have the name of the drug administered, dispensed, or prescribed. It should have the drug form. Is it a tablet, a capsule, a liquid, etc.? It should have the drug dosage. And the form will go right along with the route. So maybe the drug form is injectable and it's a liquid and you're giving it intravenously. Or maybe the drug form is a solution and it's an oral medication. It'll have the drug dosage, as well as the frequency of administration, meaning how often the person's supposed to take it. Is it every 6 hours, twice a day, every 2 hours? And any special instructions for taking the medication, such as with or without meals, in the morning, so on and so forth. So math fundamentals. First we're going to talk about a little bit of the history. Sorry, my dog's behind me being super goofy. He lost his tail. In order to start calculating and understanding why we do conversions, you need to know a little bit about the history of pharmacy math. So the apothecary system was the original primary method for calculating and measuring medication doses. However, this system is really outdated and we don't use it anymore. But pharmacist or chemist was formerly known as an apothecary. And this was replaced by the metric system, which you should be more familiar with, in the first half of the 20th century. The metric system is the primary method for measuring weight, volume, and length throughout the world. It evolved into Le Système International des Unités. I'm guessing that's French. I don't speak French, so if that sounded wrong, it totally was. Or it can be called in English the International System of Units. It's the primary method of measurement in medicine, and this is what we're usually going to be converting the way that people in the United States think. So pounds we convert to kilograms, inches we convert to centimeters and meters, and ounces that we use in America we convert to liters, milliliters, and then liters. So, the metric system, weights and measures, is referred to as a decimal-based system because it's based on multiples of 10. And this is why the metric system is so beautiful. It's easy to follow, unlike ounces and inches and pounds. There are 14 prefixes used within the metric system to describe the size of a metric unit. So here you go. Common prefixes. Micro is usually 1 over 100. Oh, they missed a 0 in there. Micro is usually 1/1,000,000th of a unit. Milli is 1/1000th of a unit. Centi is 1/100th of a unit. So this is all less than 1. So if you have a centimeter, you have a 1/100th of a unit. Deci is 1/10th of a unit. Deca is 10 units, hecto is 100 units, and kilo is 1,000 units. You can kind of cross out deci, deca, and hecto. We don't use those a whole lot. And micro is pretty, not as common as milli or centi. So a meter, noted by the small m, measures length. A liter, noted by the large L, measures volume. And this is for liquids. A gram is usually noted by a G, or you could see a GM. Measures mass or weight. So if we go to table 31.2, common metric units used in healthcare, we already talked about grams. You could have milligrams, which is 1,000th of a gram. You could have micrograms, which is even smaller. Usually for units, we have to write that out because if you just write U, people are prone to make errors with that. And if you keep going through that table, you'll kind of see some other examples of how we measure things in the healthcare system. For all units except liters, we use lowercase letters. Liters is always in capital L, even when it follows milli. So milliliters, you still get that capital L. And you leave a full space between a number and a unit. In addition, there are no commas in long numbers per international convention, but you will see commas probably in the book. That's what I've noticed. And we use commas commonly in the United States, so I don't think you should get used to not seeing them. So also, we want to avoid mixing symbols with names spelled out in the same expression. For example, we can either do 8 kg over L, the big L, so that's 8 kilograms per liter. We don't want to do 8 kg and then write out liter, right? Use Arabic numbers for whole numbers, so 1, 10, 100, 1,000. And fractions are converted to their decimal equivalents for quantities less than 1. This is just for ease of calculation. A 0 should always be placed before decimal points for numbers less than 1 to avoid confusion. Because if you put 0.1, somebody might just read that as 1, so we want 0.1. And metric units do not have singular or plural form, 5 ml, 2 ml, 60 mg, no s at the end. Arabic numbers always precede metric units of measurement, so there's always a number before the unit of measurement. Grams are abbreviated, we talked a little bit about this before, by writing GM or G. The preferred abbreviation is G, but you might see GM. When measurements or symbols are named after a person, we capitalize them. So Celsius and Fahrenheit is listed with a capital letter. So we do a lot of conversions. We switch from one unit to another, and this is where people start to get a little confused. When physician orders a medication and a unit not available, such as a physician ordering a medication in milligrams, but the drug is measured in grams, we have to convert from milligrams to grams. So 31.3, let's see. 31.3 gives you some common units used in the metric system, so the conversions, right? So, for example, let's look right at the bottom. This is probably one of the easier ones. 1,000 grams is equal to 1 kilogram, whereas if you go the other way and you had 1,000 milligrams, that is equal to 1 gram. So you need to get used to moving in those levels of 10. The shortcut or counting method, they kind of skipped over the conversion factor method, I believe. So if you know that there's 1,000 milligrams in every gram, and there's 1,000 grams in every kilogram, you can kind of figure out how many milligrams are in a kilogram by multiplying. It's hard to explain in a PowerPoint, and I can't draw on it or anything, but the book does give you some good examples of converting. So 5 grams equals blank milligrams. Step 1, you're going to write down the initial measurement and place it over the number 1. You're creating a fraction there. Next to this, you're going to create a second fraction. So 5 grams over 1 equals 1 milligram over x. So we have to solve for x, and the book moves you through that. Now, overall, if you knew that there was 1,000 milligrams for every gram, you could multiply 1,000 by 5 and get 5,000 milligrams. So the shortcut or counting method is another method that can be used, and this goes on table 31.4. Hopefully that will help you use this method. And this involves moving your finger up and down that box and figuring out how many, what conversion you need to use to get to your answer. Household measurements. We are familiar in America with this system because we use it in our everyday life. So pounds for weight, drops for volume, teaspoons, tablespoons, cups. And unfortunately, when we get into a healthcare setting, we need to be able to convert these into the metric system. So there's a conversion to go from teaspoons to mLs. There's a conversion to go from pounds to kilograms. That's the end of this slideshow, but I want to talk a little bit more about common household measurements. So let's talk, for example, so 1 ounce, which we're commonly used to measuring things in, right? 16 ounces, 8 ounces, 16 ounces is a pint for us, 8 ounces is a cup. 1 ounce has 30 ml. So if you have an 8-ounce cup, you have 8 times 30, or 240 mLs. 1 teaspoon is 5 mLs. If you have 3 teaspoons, you have 15 mLs. So really, table 31.6 is very important. It's going to help you with a lot of your homework. And the most important, I think something I use every day in my career, is converting pounds to kilograms. So if you have, the conversion is for every kilogram, there are 2.2 pounds. So normally we weigh ourselves in pounds, right? So if I want to figure out how many kilograms I am, I'm going to divide my weight by 2.2, and that will give me the answer. If you have kilograms, you would multiply by 2.2 to get the pounds answer. So remember, kilograms are always going to be smaller. So if you're trying to go from pounds to kilogram, divide. And pounds are always going to be bigger. So if you're trying to go from kilograms to pounds, you want to multiply by 2.2. Last but not least, 2 spoons, 8 ounces. Table 31.5 talks a little bit about some more conversions. That has the pint, quart, cup reference. That's not used as much, but it is good to know that a pint is 16 ounces and 2 pints equals a quart and 4 quarts is a gallon. That's just good stuff to know for when you're baking or cooking, or maybe even doing a little bit of medication calculation in your career. So I think that covers this week. I know you guys are probably a little overwhelmed. Try to move through the book's examples for conversions. It'll be really helpful for you in the long run in order to get comfortable with converting between milli to grams and then grams to kilograms. And if you have any questions on the homework, feel free to ask. I can always try to walk you through it on email. I hope you guys have a great week, and I'll talk to you soon.